In our paper, we focus on class incremental learning, which is a scenario where the model has to learn from a sequence of tasks that contain different classes. The model has to maintain the high performance on all the data seen so far. However, it cannot access the previous task data while learning the current task. And we also focus on the exemplar-free scenario, where it cannot store any data from previous tasks in memory for replay. In our paper, we investigate knowledge distillation in class incremental learning. Standard knowledge distillation methods for continual learning save the teacher model after all the tasks learned so far, and use the frozen teacher for the knowledge distillation. We notice, however, that it's beneficial to allow the teacher to adapt to new data through updates of its normalization statistics, and therefore we allow the batch normalization statistics to adapt while propagating the data through teacher model. This leads to reduced representation divergence when learning new tasks. It also reduces the knowledge distillation loss and does not affect the cross-entropy loss over the course of learning subsequent tasks. The final outcome of our method is increased stability and therefore increased accuracy in comparison to standard knowledge distillation where the teacher is not adapted. In our paper, we evaluate teacher adaptation on standard continual learning benchmarks such as Cypher 100, Tiny ImageNet 200, and ImageNet 100. We show that our method improves the results on different splits of those benchmarks and with various knowledge distillation techniques. In addition to this, we also evaluate teacher adaptation on fine-grained classification and on domain net. Interestingly, our method leads to bigger gains when evaluated on the longer sequences of tasks. And for the full results, I encourage you to check out the paper. We also invent the synthetic benchmark from continual learning that allows us to control the severity of the distribution shifts between subsequent tasks by adding noise of different severity to every other task in Cypher 100. We evaluate standard knowledge distillation and teacher adaptation on this benchmark, and we notice that when increasing the severity of the noise, the difference between standard knowledge distillation and teacher adaptation becomes bigger. This means that teacher adaptation allows the learning under bigger distribution shifts and therefore should be more robust to real-world scenarios. Main takeaways from our paper are that adaptation of the teacher model leads to increased performance in class incremental learning, and you should always pay attention to what happens in the normalization layers of your model, especially in settings such as continual learning, where we are likely to encounter significant distribution shifts in our data. Finally, I wanted to thank all my co-authors and all the institutions that made this research possible. Thank you for your attention.